So I see only 47 students. Abandi bari hehe ko ntababona? Abanyeshuri bagiye he uyu munsi, habaye iki? Mushyireho kamera turebe. Nese ejo nta group zabayeho ko bari benshi. Kanze printing attendance y'abantu ndi kureba hano, ndabona ntazi aho ko byagenze aho mwagiye. This is the last class, guys.
Teacher, I think some of us are in group.
You are in a group?
Yeah, maybe. Teacher.
Yes. So let's continue. Remove the camera, it's okay. So we are going to look on trichomonas that cause trichomoniasis. Trichomonas vaginalis is a flagellate. It moves by flagella and has a worldwide distribution. Incidence is not high in a normal female, but is very high in sex workers and prisoners. So this is how it looks like. It has 4 flagella. 5 flagella. The trophozoite is around 15 micrometers and is a half pear-shaped. The screen is shared, my dear. Screen is shared. There are 4 anterior and 1 lateral flagellum. They are attached to unrelenting membrane. There are 2 axostyles arranged asymmetrically. Organism does not assist. This is an exception. Trichomonas never form a cyst. It is always a trophozoite. Infective stage is a trophozoite. Diagnostic stage is a trophozoite. Sorry. So those are the flagella, and also we have this one, telio, and this is an axostyle. This is how they look like on microscope from the vaginal secretion or vaginal swab or vaginal discharge. Trichomonas vaginalis. Life cycle. Trichomonas vaginalis colonize the vagina of women and the urethra, sometimes prostate of a man. Infection occurs primarily via sexual contact, but non-venereal infections are somehow possible, but not really common. Organism does not form a cyst, as I said, and divided by binary fission, which is favored by low pH acidity. There is no human reservoir for these parasites. Trichomonas vaginalis, normally, it resides in female lower genital tract and male urethra and prostate, and it replicates there by binary fission. The parasite does not appear to have a cystic form, no cystic form of this parasite, and even it doesn't survive well in the external environment. It's a direct transmission. It requires direct transmission. It's transmitted among humans and its only known host primarily by sexual intercourse. So the sexual intercourse, unprotected one, is the way of transmission of this. The symptoms consist of
You're muted.
okay. Trichomonas vaginalis infection is rare symptomatic in men, although it may cause mild urethritis or occasionally prostatitis. So the man, they can be carrier of this parasite and they keep spreading or contaminating female. Because the man may not have clinical presentation while they harbor this kind of parasite. In women, it's often asymptomatic, but heavy infection in higher pH environment
Lecture, you are muted.
You are muted, lecture.
So, clinical diagnosis. You can suspect of having this infection by clinical presentation of the patient, and then a vaginal discharge or vaginal swab can be taken and analyzed on microscope for observing the trophozoite of this Trichomonas vaginalis. Is very characteristic on wet mount preparation on microscopy. The treatment is like other protozoa by metronidazole, and the treatment is effective in both male and female. However, once one partner is diagnosed of having this parasite, it's better to treat the whole couple because it's a sexually transmitted disease. So if one of the couple is treated, most likely the other one is infected, either a carrier or asymptomatic, and will again start a new infection. That's what really complicates the situation if one of the partner gets treatment and the other one is not treated. Infection will not go away because you will keep getting reinfected. So if we can just have a look here, of Trichomonas vaginalis, how it looks like on microscopy. Let's show you this one. It's a flagellate and it has a flagella. There are 5 flagella that helps the parasite to move. So let's have a look.
You are muted.
I was saying that that's the particular morphology of Trichomonas vaginalis, and it's very characteristic. You can't really confuse it with something else. So, and it's simple to diagnose. Once you feel you have lower abdominal pain and those discharges that have a bad smell like rotting fruit, just go to the lab, provide the vaginal swab, and then direct microscopic observation will reveal those moving parasites as you saw them on microscopy. Treatment is metronidazole, as I said, and also you have to treat your partner if you have, so that you make sure you eliminate the infection in the family. So I think I'm done with the parasite that affect intestinal and urogenital tracts. Now allow me to move to blood and tissue parasite. Blood and tissue protozoa. Here we have different categories. We have the flagellate, including trypanosoma. We have different trypanosoma, including trypanosoma brucei, brucei rhodesiensis, brucei gambiensis. We have also trypanosoma cruzi from South America. We have leishmania that has leishmaniosis, cutaneous and visceral leishmaniosis. As well, we have also Plasmodium falciparum, Plasmodium ovale vivax malariae that cause malaria infection that affect the red blood cells and cause anemia. And also we will see Babesia. Babesia is a parasite also that is that will look like Plasmodium. And in addition, we will see the Toxoplasma gondii. I think we are going to have on discussion on those two. Let's now start from this flagellate. Trypanosoma, which are blood protozoa of major clinical significance. And we have this category: Trypanosoma brucei, gambiens, and rhodesians, and the Trypanosoma cruzi. Leishmania donovani cause leishmaniosis, visceral leishmaniosis tropica, and Braziliensis that cause cutaneous leishmaniasis. Then Plasmodium and Toxoplasma as well as Babesia microti will be seen later. So, trypanosomiasis, it's divided into two. One is African trypanosomiasis, which is known as sleeping sickness. Sleeping sickness because once you are infected with this parasite, you can have this kind of behavior of sleeping wherever you are. Sometimes I joke with my students saying that you can even sleep while you are eating. Imagine you are eating, then you fall asleep. It's very funny. So we call it African sleeping sickness because they were found in Africa, especially in Zimbabwe and also Gambia. The other one is Trypanosoma cruzi that is found in South America that cause Chaga disease. There are two clinical forms of African trypanosomiasis or African sleeping sickness. There is a slowly developing disease that is caused by Trypanosoma brucei gambiens, while we have also another rapidly progressing disease caused by Trypanosoma brucei rhodesians. It was found in Zimbabwe. So, Trypanosoma brucei gambiens is predominant in the western central region of Africa, while rhodesians is restricted to East Africa. Regional epidemics of the disease are caused by major health and economical disasters. But in addition to that, there are need of vectors. The presence of vectors contributes to endemicity of the disease. The vector for this Trypanosoma brucei is tsetse fly. So the existing of tsetse fly in the region will contribute to the endemicity of the disease or the parasite. Brucei gambiens and rhodesians are similar in appearance. The organisms are around 10 to 30 micrometer in size, and it has a single central nucleus, single flagellum, joined to the body by an undulating membrane. This is how they look like, and also they are very simple to be recognized on microscopy. This is the parasite, and both rhodesians and gambiens, we can't differentiate them morphologically. So the life cycle is as follows. Infective metacyclic. Metacyclic is an infective form of this trypanosoma. So it should be injected into primary host during a bite by the vector. The vector, as I said, it's a tsetse fly. So the organisms will transform into a dividing trypanosome called trypomastigote in the blood. As they enter to the lymphatic and the blood stream, trypanosome form trypomastigote will enter the vector during blood meal and travel through the alimentary canal to the salivary gland where they will proliferate to the creditio form, which is an epimastigote form, and mature to the infectious form, which is a metacyclic form. So this is the life cycle in tsetse fly, and this is the life cycle in a host. This is a tsetse fly in the family of Glossina. We say Glossina parparis, which is known to cause or to be a vector of this parasite. Although it's a fly, they are not the same as the house fly that we are having in our region. They are very special fly, and even they have the sucking needle. We call it a proboscis. Proboscis like the one for mosquito that is used to suck blood. You know that the house fly, they don't feed on blood. But this Glossina parparis or tsetse fly, it can feed on blood, and during blood meal, that's it take the parasite, and the parasite will undergo some development stages that will come to the metacyclic tripomastigote, which is an infective stage of this parasite. So trypanosomiasis, a tripomastigote can traverse the wall of the blood and lymph capillaries into the connective tissue, and at the later stage can cross into the blood-brain barrier and reach the cerebrospinal fluid. Organism can be transmitted through blood transfusion too. And once it reaches the cerebral area, the meninge, it can start causing those signs of sleeping sickness. So the life cycle occurs by bite by tsetse fly or Glossina parparis, which come to take a blood meal and inject metacyclic tripomastigote into human being. Then this injected metacyclic tripomastigote will transform into the bloodstream, into tripomastigote, which are carried to other side or other body sites. Tripomastigote will multiply by binary fusion in various body fluids, in the blood, in the lymphatic fluid, and even in the cerebrospinal fluid. This tripomastigote in blood will also be taken by tsetse fly or Glossina parparis during another blood meal. And then a bloodstream tripomastigote will transform into procyclic tripomastigote in tsetse fly midgut. Midgut is like the stomach of the insect or the fly. Then procyclic tripomastigote will multiply again by binary fusion, whereby procyclic tripomastigote will leave the gut of the fly and transform into epimastigote. This epimastigote now will need again to multiply and migrate to the salivary gland of the fly and transform into metacyclic tripomastigote in the salivary gland of the tsetse fly or Glossina parparis. So now, once it is in the salivary gland of the tsetse fly, metacyclic tripomastigote can be injected to human being once there is another blood meal to the human being. That's how the life cycle occurs for this parasite. And the human are the main reservoir for this Trypanosoma brucei, either Gambians or Rhodesians, but these species can also be found in some animals. The clinical presentation for Gambian and Rhodesian disease are the same, but they vary in severity and even in duration. For instance, Rhodesian disease caused by Trypanosoma brucei rhodesians can progress more rapidly and the symptoms are often more pronounced. Clinically, the progression of African trypanosomiasis can be divided into 3 stages. There is what we call the bite reaction, also known as chancre. There is also a parasitemia, presence of parasite in blood and lymphoid tissues, and the last one is central nervous system involvement. Bite reaction, it's a painful itch chancre form of 1 to 3 that occurs 1 to 3 weeks after the bite, and it can last 2 weeks and it leaves no scar. While parasitemia or presence of the parasite in the bloodstream, as well as the lymphatic tissue, the lymph node invasion is marked by attack of fever, which starts 2 to 3 weeks after the bite, and is accompanied by malaise, lassitude, insomnia, headache, and lymphadenopathy, and even edema. Very characteristic of Gambian disease is very visible enlargement of the gland of the posterior cervical region. We call it winter bottoms sign. So, this is the site of infection. This one, bite reaction. This is the bite reaction caused by tsetse fly. This is the winter bottom sign caused by trypanosoma that goes into the lymph node. Central nervous system stage now, the latter is marked by change in character and personality. They include lack of interest and disinclination to the work. You don't feel comfortable to work. Mental retardation, low and tremulous speech, tremors of the tongue and limbs, altered reflexes, malaise, may become impotent. You lose sexual activity, and once it progresses, you start having those signs of sleeping. There is a slow progression involvement of cardiac tissue. The later stages are characterized by drowsiness, uncontrolled urge to sleep, where you can sleep even on the table during lunch. Terminal stage is marked by wasting and emaciation, death result from coma, cardiac failure, and so on. This is a young boy victim of sleeping sickness. Clinical features of Rhodesian disease are similar but briefer and more acute. The acuteness and the severity of disease do not allow typical sleeping sickness. Death is due to cardiac failure within 6 to 9 months. Then, pathology and immunology. An exact pathogen of sleeping sickness is not known, although immune complexes and inflammation have been suspected to be the mechanism of damage to the tissue. The immune response against the organism does help to eliminate the parasite, but is not protective since the parasite has a unique ability of altering the antigen, surface antigen. This is the ability of the parasite to change their surface antigen so that they confuse immune system. Imagine you come as a robbery or a thief, you are having a red jacket. So everyone who will see you will say, the robbery was in red jacket. So the policeman will try to find out where is the guy in red jacket. So everyone will be sympathized to catch the robber or the thief in the red jacket. But when you run away in 2 meter or 5 meter away, you hide and change the jacket, you come with the black one. So you will pass it on the police, smoothly saying, oh, you see, I'm not the one because you have changed the jacket. And the police will not recognize you because they are searching for the one in red jacket. So the same for the parasite, it alters the surface proteins or surface antigen. Those antigen normally they are recognized by the immune system. So once they are changed, they are not recognized. They will escape immune recognition and so on. So that's how they evade or escape immune recognition. Detection of parasite in the bloodstream, lymph secretion, and large lymph node aspirate will provide the definitive diagnosis. We look at those parasites. Cerebrospinal fluid must always be examined for organism. CSF. Immunoserological like enzyme immunoassay or ELISA immunofluorescence may be indicative but does not provide definitive diagnosis because previous exposure and current or acute phase, both immunological tests are positive. The most effective means of prevention is to avoid contact with tsetse fly or Glossina pulparis. Vector eradication is impractical due to the vast area involved. Immunization has not been effective due to antigenic variation of that parasite. The treatment, sleeping sickness, is notoriously difficult to treat considering the toxicity and complexity administration of the drug currently available for treatment. Only 4 drugs are registered for treatment for African sleeping sickness, including pentamidine, silamine, merazoprol, and even eflornithine. Those are the drugs that can be used for this parasite. Let me try to see if I can find the parasite here on image. Let's see if we can see them. Yeah, we can see them on a stained smear, but also they can be seen on an stained smear as a direct parasites. So let's see one of them. Like this is a blood, unstained blood. Just you take a blood sample, you put on a slide, and after putting on a slide on microscope, you will see things like this. Do you see them? Moving things. Guys, are you seeing something? Sorry.
Yes, we are seeing something.
We're seeing it.
Yeah. Diagnosis is simple. You take a drop of blood sample, you put on a slide, then you put on microscope, you will see those parasites moving. But if you perform a smear or a stain, you will not see them in that way. Probably you will see them yes. Sorry? Which one? Try to be specific. Cryptosporidium is intestinal protozoa. And this one, intestinal protozoa, but this one is a blood protozoa. In addition to that, Cryptosporidium is among apicomplexan parasites. It doesn't have locomotive appendices. But this one, Trypanosoma, is a flagella. It's a flagellate. It has flagella for movement, and it affects bloodstream and lymphatic tissue as well as central nervous system. So they are not the same. Okay. Yeah, now let's see American trypanosomiasis or Chagas disease. The difference in morphology is that Trypanosoma brucei is coiled. You can see how it's coiled. It's not straight. We normally see it. You can find them which are straight, but among others, we find this form of coiled parasite, and this is the characteristic that help to differentiate from Cruzai to Gambians or Rhodesians. In addition to that geographical distribution, some are in Africa, but this one is in America. So those are Trypanosoma cruzi. The vector for Trypanosoma brucei is tsetse fly in the genus of Glossina purpuris, but here it's a kissing bug that transmit this kind of infection. Kissing bug, also known as Triatoma. Triatoma infestus is the genus that transmits disease. Triatoma infestus, kissing bug, or Lidivid bug. Those are the names that of this parasite, either Triatoma infestus, kissing bug, or Lidivid bug. That's the vector of Triatoma or the vector of American trypanosomiasis. Life cycle is not really big different from that of brucei, Trypanosoma brucei. You can see that a man is infected by triatomine bug, which come to take a blood meal, passes metacyclic trypomastigote in feces, and trypomastigote enter the bite wound or mucosal membrane, such as the conjunctiva, and penetrate the body. So the difference, the small difference is that for Trypanosoma brucei, the infective stage, metacyclic trypomastigote, is found in the proboscis or in the mouth of tsetse fly. But for this one, the triatomine bug or kissing bug, metacyclic trypomastigote is found in feces, in the stool of the kissing bug. Once the kissing bug comes to take a blood meal, then it will defecate to the skin. Then the parasite within the feces of the parasite will enter into the body through the bite wound and penetrate to the body. In the body, metacyclic triple mastigote will penetrate various cells at bite wound site. Inside the cell, they transform into a mastigote. A mastigote will multiply by binary fission in the cell of infected tissue. Intracellular, a mastigote will transform then burst out the bloodstream. So the cycle. So I'm saying that in human stage, metacyclic triple mastigote will penetrate various cells at bite wound site. Inside the cell, they will transform into mastigote. This is not common, it's not the same for brucei, because brucei is not known to infect the cells at the site of infection. Then these mastigotes will multiply and infected tissue will burst. Infected cells will burst. Intracellular mastigote will transform into triple mastigote, then burst out of the cell and enter a bloodstream and cause another infection. Triple mastigote can infect other cell and transform into intracellular mastigote again in a new infection site. Clinical manifestation can result from this kind of infective cycle within the body. Then later on, if the kissing bug comes to take another blood meal, this triatomine bug or kissing bug will come and take a blood meal and it will absorb triple mastigote, which will be ingested and will transform into epimastigote in the midgut of the kissing bug. Then will multiply in the midgut and then will transform into metacyclic triple mastigote in the hindgut. We have midgut and we have hindgut. Instead of parasite to go to the proboscis on the map, it will go backward to be eliminated in feces of this kissing bug or triatomid. So once eliminated in the feces, this parasite will again enter to the body through the bite site or the bite wound, and infection will continue like that. So to kill the parasite, Chaga disease can be treated with benzimidazole and also Niftimox. Both medicines are almost effective in curing this disease if given soon after infection. The efficacy of this diminishes, however, the longer a person has been infected. As you delay treatment, as treatment is less effective as far as there is involvement of central nervous system and so on. We control this by controlling vectors. There is no vaccine. Also, blood screening is necessary to prevent infection through transfusion and organ transplant in those cases, especially in endemic area. WHO recommends some activities in an endemic area, such as spraying of household. We spray with the repellent, insecticidal repellent, so that we control them, or the surrounding area with residual insecticides. House improvement and house cleaning to prevent vector infestation. Personal preventive measures such as bed nets, using bed nets when you are sleeping. Good hygiene practices in food preparation, transportation, storage, and consumption. Although this is not food related disease, but still, once we give opportunity of the vector to be around us, we can get infected. Screening of blood donors, testing of organs and tissue or cell donors and recipient, access to diagnosis and treatment of people with medical indications, and screening of newborns and other children of infected mothers without previous antiparasitic treatment to provide early diagnosis and treatment. As we have seen, that early diagnosis and the treatment is very crucial because prognosis is very good, 100%. But if delayed, prognosis is not good. So that's all I have to talk about Trypanosoma brucei, Rhodesians, and Gambians. So we have another parasite that infects, unless you have a question. Any question? Gakko, are you still there or you are gone? So, how is it? Is it okay?
Yes, it's okay.
So let's move on to this leishmania. Leishmaniasis that is caused by Leishmania tropica, Leishmania donovani, and so on. Several species of Leishmania are pathogenic for man. We have Leishmania donovani that causes visceral leishmaniasis, also known as Kala-Azar or black disease. When you have this kind of leishmaniasis, sometimes you have neurological problem and you can't. I remember the simple test that you can give a patient is to take a key and lock the door. We call it calendar sign. You take a key, you put the key in the lock, and you turn the lock to close. So the patient with this disease cannot perform that activity, cannot take a key and lock the door. We call it calendar sign. Leishmania tropica, whereby you have Leishmania tropica major, Leishmania tropica minor, and Leishmania ethiopica. All of Brasiliensis, whereby Leishmania mexicana, Leishmania peruviana are etiological agent of mycocutaneous leishmaniasis. This is South America, Brasiliensis, Mexicana, Peru, Peruviana, they are in South America. But this one, Tropica, major and minor, Ethiopica, you can understand that this is tropical area, including East Africa. So leishmaniasis is prevalent worldwide. The amastigote leishmaniiform is oval and measure 2 to 5 microns, whereas the leptomonad measure around 20 micrometers. This is leishmania within the macrophage. They are intracellular form. Leishmania tropica, amastigote form. This is Leishmania donovani, leptomonad form. Let's see the life cycle, how life cycle occurs. The life cycle here occurs by this sandfly which comes to take a blood meal and inject promastigote stage into the skin. Remember, on the trypanosoma, infective stage is metacyclic trypomastigote. But here, the infective stage is this sandfly, it's promastigote. So promastigote are phagocytized by macrophages within the body. Then once they are phagocytized by macrophage, promastigote will transform into amastigote inside the macrophages, whereby amastigote will multiply in cell, including macrophage of various tissues. Then the sandfly, which will come to take a blood meal again, will ingest macrophage infected with amastigote. Then there is a rupture of the parasitized cell. Amastigote will transform into promastigote stage in the midgut of the parasite and divide in midgut and migrate to the proboscis or the mouth of the parasite. Then will become infective promastigote that is transmitted to human during another blood meal. Leishmaniasis is transmitted by the bite of female phlebotomine sandfly. This sandfly, which inject infective stage promastigote during a blood meal. The promastigote that reach the puncture wound are phagocytized by macrophage and transform into amastigote, whereby amastigote will multiply and infect the cell and affect different tissue depending in part on the Leishmania species. This originates the clinical manifestation of leishmaniasis. Sandflies become infected during another blood meal. Then in the sandfly midgut, the parasite will differentiate into promastigote, which multiply in the midgut and migrate to the proboscis. The clinical presentation is divided into 3 categories, whereby we have visceral leishmaniasis, cutaneous leishmaniasis, and mycocutaneous leishmaniasis. Let's see the visceral one. Visceral leishmaniasis. This visceral leishmaniasis also is called Kala-Azar or Dum-Dum fever. This visceral leishmaniasis is caused by Leishmania donovani. Organisms in visceral leishmaniasis. Cutaneous. Cutaneous means the skin. In the cutaneous leishmaniasis, organism Leishmania tropica multiply locally. here, the infection is not caused by Leishmania donovani. It is caused by Leishmania tropica. These multiply locally, producing a papule. 1 week later, the papule gradually will grow to form relatively painless urethras. The center of urethra encrust while sterile papule will develop at the periphery. The urethra will heal maybe in 10 months, even if untreated, but leave some disfiguring scars. Disfiguring means you lose your figure. The disease may disseminate in the case of depressed immune function or immunosuppression. This is the skin urethra due to Leishmania tropica. This is non-healing cutaneous leishmaniasis lesion on the earlobe. Now, the last one is mucocutaneous mucous membrane. Mucocutaneous, the initial symptoms of mucocutaneous leishmaniasis are the same as those of cutaneous, except that in this disease the organism can metastasize and the region spread to mucoid, including oral cavity, oral region, pharyngeal area, pharyngitis, pharyngeal area, and even in nasal tissues and lead to their destruction and hence severe deformities. You lose all of your beauty. Organism responsible is Leishmania brasiliensis, mexicana, and peruviana. This is a girl with diffuse mucocutaneous leishmaniasis of the face, which is responding to treatment, but left the deformities or lost the beauty of your figure. Pathogenesis of leishmaniasis is due to an immune reaction to the organism, particularly cell-mediated immunity. Laboratory examination will reveal a marked leukopenia with relative monocytosis and lymphocytosis, anemia, and thrombocytopenia. Diagnosis is based on history of the exposure to the parasite, symptoms, and isolation of the organism from lesion aspirates or biopsy by direct examination or culture. A skin test and the detection of anti-leishmania antibodies by immunofluorescence are indicative of exposure. So, to control this, we have to control the vector, and immunization has not been found. Treatment. Before considering treatment, first step is to make sure the diagnosis is correct. FDA-approved medication to treat this leishmaniasis where a intravenous liposomal amphotericin B can be used for visceral leishmaniasis and oral miltefosine for cutaneous leishmaniasis, mucocutaneous leishmaniasis, and visceral leishmaniasis caused by particular species. Ketoconazole and fluconazole antifungal drugs may also be used for some species and showed to be helpful. So, I think I have been so fast for this presentation, but we still have this parasite. So, Can we take a break or we go for lunch? Then we finish this presentation maybe in 1 hour in the afternoon? What do you
Yes.
think?
Yes, you can.
Yes. We can take a break now, and in the afternoon from